So I'm going to go ahead and get started. I know we still have a couple folks trickling in, but there's a lot of stuff I want to cover, and we have 35 minutes to do it. And I want to leave a bunch of time for questions at the end. So let's see. Maybe if I can get through the kind of slide portion in 15 minutes, then we'll have 10 minutes for a demo and 10 minutes for Q&A. So this is the introduction to Linkerd talk. Hopefully that's not a surprise for any of you. My name is William Morgan. I actually don't have a slide about myself on here, but just imagine, an incredible life story culminating in me creating this service mesh just by myself, from pure genius inspiration. Yeah, thank you. Thanks. I am Linkerd. Yeah. No, so the reality is Linkerd is a community project. It's a CNCF project. There are many, many people who have spent a lot of blood, sweat, and tears on Linkerd, and I am ostensibly a maintainer of Linkerd, but I'm really, these days, I'm mostly the maintainer of the README, and I don't do a whole lot of coding, but I do a whole lot of talks like these. So thank you again for coming here, and I'll try and make it worth your while. So what is Linkerd? It is a service mesh. I'm going to spend a tiny bit of time going over what a service mesh is. It's an open source. Linkerd is an open source project. It's a CNCF project. Hopefully you saw the keynote update this morning with Brian Lyles. All sorts of activity going on. We have a very, very healthy community. Been in production for over 3 years. A lot of friendly folks on the Slack channel. Lots of GitHub stars, of course, very, very important. And a ton of contributors. And so, by being in this room, I want to invest in you the power to Linkerd. You are already members of the Linkerd community. So you're already a part. And all sorts of fancy production adopters, which is also important. Okay, so, Linkerd is a service mesh. What does a service mesh do? And typically, I like to break this down into 3 general categories, right? One category is around observability. Okay, and one category is around reliability, and one category is around security. So on the observability side, what Linkerd can do is give you, there's a lot of stuff, but one of the things we can do is we can give you what we call golden metrics, which are things like the success rate and the latency distribution and the request volume of the traffic going to and from a service. We can draw a service topology for you. We can do distributed tracing. There's a bunch of other fun stuff we can do, and I'll show a little bit of that in the demo at the end. You can also, there's a bunch of cool reliability features that it gives you, primarily oriented around kind of synchronous HTTP calls. So things like retries and timeouts and load balancing and circuit breaking are all things that Linkerd can do. And then there's a set of security features. Often we talk about mutual TLS, which is TLS where we validate certificates on both sides. In contrast to your web browser talking to a website. You'll validate the identity of the website, but the website doesn't really care about your identity. In mutual TLS, we care about identity on both sides. So that gives us both encryption and identity. And most important for us is we do all this in a package that is focused on operational simplicity, which means that when you add a service mesh to Kubernetes, we don't want to make it any harder than it really needs to be, right? You've already gone through the exercise of adopting Kubernetes and its massive API surface area. We don't want then the service mesh to be like an additional 700 things that you have to worry about. So a big focus on Linkerd is how do we provide these features for you in a way that is as easy as possible, as simple as possible, and especially from the operational aspect, the least burdensome possible. You can see a couple screenshots of our fancy dashboard. I'll also show that as part of the demo. Okay, so that's like the what, but I think what's more interesting is the why should I care? And I actually just wrote a very, very long form version of this slide at servicemesh.io. It's like a 15-page meshifesto. So if you are bored, yeah, I just came up with that term. So if you are bored or you have a long flight home or whatever, feel free to check out servicemesh.io. But so why should I care, right? So the reason why Linkerd is interesting and the reason why any service mesh is interesting is I think there's a couple aspects. There's a who, there's a what, there's a why, and then there's like what's the magic element, right? And the who for the service mesh is primarily what we call the platform owners, which are the SREs, the architects, the folks who are building the internal platform for their organization. That's the immediate target audience for Linkerd. Now the service owners, who are the developers who are building code on top of this platform, they also get a lot of value out of this, but they're kind of a secondary audience. Okay, and how do we make the platform owners happy? Well, we give them those primitives, right? And we give them in a way, and these are primitives that are critical for cloud-native architectures, right? That's kind of an opinion, but I believe it's true, right? And we give them in a way that requires no developer involvement. And that's kind of the magic, is that we want to give you these things that are ultimately platform features. We want to give them to you at the platform level so that a developer doesn't even know necessarily the service mesh is there, right? They're happily producing sweet business logic, and the platform is supporting them and like just making that all execute in a nice way. That's the goal, right? And seeing through that lens, I like to say that Linkerd doesn't solve technical problems so much as it solves socio-technical problems. It decouples the platform owners from the developers. So rather than you relying on the developers to implement TLS, and for every team to use TLS in the exact same way, you can solve it at the platform level, right? Same thing with reliability features. Same thing with the observability features. It's not a complete solution in any of these domains, right? There's a lot more to observability than just looking at service success rates. There's a lot more to reliability than doing like, retries on HTTP GETs. And there's certainly a lot more to security than just adding a bunch of encryption everywhere. But it gives you, Linkerd gives you this platform-centric slice of those features. That makes sense so far? Okay, so I talked a little bit about this. There's a bit of history in Linkerd that I'm mostly not going to go into, and I'm going to talk about the modern version of Linkerd, which is the 2.x branch. 2.6 is the most recent version. 2.7 will be released later this year, and so on. Right? And here we have some very explicit design goals, which is we want Linkerd to do the least amount of things possible. Right? So every feature you add is like a cost. Right? It expands the surface area, expands the operational complexity. So we're trying to do less, not more. Right? And we've got a couple design principles. So the first is we want it to just work. Which means if you have a functioning Kubernetes application, you install Linkerd on top of it, your application should continue to work. That's right. Yes. It's genius. Right? It turns out it's actually really hard to do. So we've got all sorts of fancy protocol detection and things like that. Ultralight, of course, we want to reduce as much as possible the computational burden, right? Which means not just the CPU consumption and the memory consumption, but especially the latency, because that's actually what's going to end up being user-facing in a very direct way. And then, most importantly, simplicity, right? We want to reduce the operational complexity in every possible way. So modern Linkerd 2.6 and beyond, control plane is written in Go, takes about 200 megs of memory if you don't include Prometheus, which slowly grows over time as you throw more metrics in it. Has a data plane written in Rust, which is a super cool language, and there's lots more to say there, but that runtime is really, really small and really, really fast. And then I also wrote, I think earlier this year, a long story about some of the history, because the first version of Linkerd, the 1.x version, was actually written on the JVM, and we had to do a slightly painful translation from the JVM to Rust and to Go. And then I think at the end here, I actually have a couple more, I have a slide with a couple more links to talks at the rest of KubeCon San Diego. But one of them, if you want to get, if you want to graduate from intro level to like deep dive level, my colleague and the real creator of Linkerd, Oliver Gould, is giving a Linkerd deep dive later in this conference. Okay, so this is what Linkerd looks like from the architectural perspective. I'm not going to go into too many of the details here, but you can see that it's roughly divided into a control plane and a data plane, right? And the control plane has like all sorts of bits and things that do things, and the data plane actually looks very simple here, right? But when you deploy this thing, the control plane, you have between 1 and 3 kind of replicas. The data plane, you may have hundreds or thousands or tens of thousands of replicas. So this is just the conceptual diagram. And in here, every blue box is like a Kubernetes pod boundary. And so in the data plane section, you can see that the way this works, as with not all, but many service meshes, is we add a little proxy called Linkerd proxy here, and it gets jammed right next to, in fact, it gets jammed in the same pod as your service, your application instance. And we do some wiring so that all TCP traffic automatically goes to and from that proxy. And there's all sorts of reasons. there's upsides and there's downsides to this approach, obviously. There's like, we're adding proxies everywhere. In fact, we're adding 2 proxies to every hop, right? Because when A talks to B, it goes through its proxy and then through the destination proxy. So there is an impact to doing that. You're running a lot of proxies. We're all introducing latency. But there's also lots of benefits because it means that the proxy can control the client and the server side of that connection, which means we can do stuff like TLS. So lots more detail in that long article I wrote on servicemesh.io. But that's the basic idea. And what's nice about Kubernetes is that it gives us ways of doing this that are not completely insane, right? Like, it makes this a feasible thing to actually deploy, as opposed to trying to, manage 10,000 proxies yourself with Ansible or whatever, which is how I grew up. Okay, how fast/small is it? We did some benchmark, a company called Kinvoke did some benchmarks. You can read their blog post about it. It's, I guess the TLDR is that it's fast, but it's a lot worse than not having a service mesh. So if you really want to be fast, don't have the service mesh at all. But it's also a lot faster than Istio. When we do Q&A, the very first question should be, what's the difference between Linkerd and Istio? So get ready for that. And you can find this online. This is from May, so it's a couple of versions ago for both projects, so things may have changed. Okay, and we are more or less on track for time, if I can stay focused here. Okay, so roadmap. As of 2.6, which was announced last month, or released last month, we've got all sorts of crazy features. Distributed tracing is in there. Lots of caveats about distributed tracing, but we support it. Traffic shifting is in there, so you can shift like a percentage of traffic from one service to another as part of like a blue-green deploy or something like that. Great telemetry, I'll show that off, and retries, timeouts. Proxy auto injection, which means you're not, all the injection stuff where we add that proxy into the container of the application instance is all done on the server side. So you're not doing anything at deploy time that even looks special. You're just like deploying your stuff as usual. Mutual TLS on by default for all HTTP communication. Crazy. The moment you install Linkerd and you add the data plane to your service, all HTTP communication is automatically TLS'd. You don't get a choice. Well, you can turn it off, but it's on by default. I think that's really important because security works best when it is free, right? And the harder you make it, right, the less inclined people are to do it, and the more configuration that's involved. Well, you leave that thing for later, right? But when I use my web browser and I'm connecting to Reddit and looking at cat pictures or whatever, I get the green lock icon, and I haven't done any work on my side, so why should my services, which are handling PCI data or whatever, why should that be worse, right? That should be at least as good as Reddit cat pictures. And then later this year, 2.7, the target is mutual TLS for all TCP traffic, so not just HTTP. Really thorough MTLS auditing, so I want to give you, this is clearly like a security theme here. We want to give you really good introspection into what is TLS and what is not, because sometimes it's not clear. Rotating certs in the control plane, all sorts of other fancy stuff. And then getting into next year, policy. So right now, Linkerd just says yes every time you want to make a connection. Sometimes we might want to say no, you're not allowed to make that connection. So that's policy. Enforcing TLS, so not allowing non-TLS connections to happen. Mesh expansion, which is like, can I talk to things outside of, can I run the data plane outside of Kubernetes? And there's lots more. Oh, multi-cluster is a big one. Yeah.
So that is a very basic roadmap. Briefly, I will just say there is a lot of Linkerd content at KubeCon this year, which is very exciting for us. All the stuff on Tuesday you've basically already missed because the only other Linkerd thing that hasn't happened is happening right now, which is Rita and Ivan talking about OPA Gatekeeper, which is a really cool project. But everything gets recorded, so you can always watch these things afterwards. And then tomorrow, Anna and Risha are going to be talking about some really cool stuff that they did with Linkerd at Paybase. If you're into functions as a service, you have Alex and Charles talking about OpenFAS. And then Oliver, like I mentioned, will be doing a deep dive. And then finally, Brian Redmond from Microsoft on Thursday will be talking about supercharging your microservices CI/CD. There's a lot of content on all these things. What I'm going to try and do now is give you a very brief demo of Linkerd. And then if I can wrap that up in time, and if the demo gods are with me, we'll have a bunch of time for a Q&A. Making sense to everyone so far? All of these slides are actually, well, they're on sketch.com, but there's also a Linkerd, they're derived from this Linkerd meetup deck, public meetup deck. So if you want to go and talk about Linkerd and become a Linkerd hero, impress your peers, you're welcome to use these slides. It's all on linkerd.io. So let me try and give you a very brief demo. Okay, so I'm going to be doing this with like Docker for Mac. We'll see how this goes. All right, so here I am with my kubectl cluster, nothing up my sleeve. The very first thing I'm going to do is I'm going to apply, so before I do any service mesh stuff, I'm going to apply this manifest. And I've been using this manifest for like 3 years, so I know this application pretty well. Okay, so it creates this namespace, emoji photo, and it's got a bunch of services that are running in there. And then if I go to my handy-dandy Kubernetes dashboard, hopefully we will see. Oh, no, not this thing. Oh, okay. Okay, I'll just run this command again and then copy and paste this thing in here again. You know, I did this right before. How long do these tokens last? It's like 3 minutes. Okay, there we go. Whew. All right, so you know, I can go to this emoji photo namespace. Clearly, there's some stuff running here, and in fact, I can even go and I can see what this app is. So if I go to localhost, you can see that it's an app for voting for your favorite emoji. So you know, we'll vote. I like the smiley ghost guy. Right? Okay, cool. I actually have a bot that's going in here that's generating traffic, so it's also voting. This is like man versus machine. And then the app has a bug in it, right? So for the sake of this demo, every time you click on the donut thing, it returns a 500 or a 404. Okay, so the reason why I like to start with this app is because you look at the Kubernetes dashboard, as far as it's concerned, everything's healthy, right? And so we're in this state now, which is not uncommon, where we have an application, we know the application's broken, but as far as Kubernetes is concerned, like everything's fine. Right? Pods are green, everything's running, nodes are up. Okay, so this is a good intro to the service mesh. So what I'm going to do is I'm going to install Linkerd. Okay, so I've got a little CLI, Linkerd version, great. And I'm going to install it. And the way install works is just emits a manifest. There's other ways of doing this. You can use a Helm chart and things, but for demo purposes, this is pretty easy. It emits a manifest, and I'm just going to pipe it right into kubectl. And it's going to create a bunch of things. Don't worry about this stuff. It's all fine. Lightning fast. Okay, and then we have this little command called Linkerd check, which is just going to validate that everything's okay with Linkerd. Okay, and it's detected that you know, this thing is not ready, so it's waiting for it. Docker for Mac is frantically struggling under the load. And what's interesting here is you can see that it is waiting for Linkerd proxy for that container in this pod. Okay, well now it's moved on to the next one. That was not called, so it was looking for a data plane proxy. Now all I've done so far is install the control plane. But one thing that we do, which I'm really kind of pumped about, is we run the data plane on the control plane, or we run the control plane on the data plane, which means that every control plane component in Linkerd has a proxy injected, which means we'll see in a second, once I have the dashboard running, you can use the exact same tools that we give you to inspect your application and to understand the state of your application, to understand the state of Linkerd. And I think that's really important because the service mesh is really confusing, especially the first time. And if you are the poor fool who introduces a service mesh into your ecosystem, then the moment that anything breaks, you are the first person who gets blamed because you just introduced this garbage technology. So I want to give you, that's what they would say. And then I'm going to give you the tools to understand and to show and to inspect exactly what's happening on the Linkerd side so that you can defend this beautiful piece of technology from naysayers. Okay, so Linkerd check says everything's okay, and then let's just spin up the dashboard. So that wasn't too bad, installing a service mesh in 60 seconds, even on a slow computer. Okay, so here's the Linkerd dashboard. It looks kind of similar to the Kubernetes dashboard, similar but different. And you can see we've got a whole bunch of namespaces here, and the Linkerd namespace is the only one that's getting metrics right now. That's because all I've done is installed the control plane, which, as I mentioned, has a data plane in it. The other namespaces have not been meshed, so there's no data plane in there yet, right? And here we can see that we are getting success rates and request volumes and latencies for each of the control plane components. So this is already incredible. Okay. So now, Emoji Vodo is still running here, right? I haven't done anything with this application. And it's still got the same problem. So what I'm going to do next is I'm going to add the data plane to Emoji Vodo. And there's a variety of ways of doing this, but for ease of use, I'm going to use this inject command. And let me see, do I actually have, okay. So what I'm going to do is I'm actually going to show you the difference. I'm going to show you what Linkerd inject does. It's just a text transform command. So what it's going to do, really, is it's just going to add this annotation that says Linkerd IO inject enabled. It's going to add that to every deployment in this manifest. You can also add this at the namespace, right? And that's the only change this is making, other than apparently reordering a line from here to there. That's the only change, right? And once Linkerd sees that annotation, then it's going to know when you deploy this thing, I'm going to inject the data plane pods. So let us inject and apply. So that's the same manifest from before. I'm going to run it through inject. I'm going to reapply it to Kubernetes. Kubernetes is going to roll the pods. And we can actually watch this live in the Linkerd dashboard. If we go back here to Emoji Vodo, what we should see in scant moments is, yeah, we can see that, well, all right, it happened so fast we could barely see it. No? There we go. So we can see that something has gone tragically wrong. No, we can see that everything was meshed. So 1 out of 1 pods for each of these deployments has been meshed, and now we're starting to see metrics come through the system, right? So we've added, without Emoji Vodo having to be changed, or without you having to do anything or write any code, we've added the proxy next to every deployment, and traffic is going through those things, and we're getting metrics out of them. By the way, we've also encrypted everything, so Emoji Vodo is fully secure. Well, not fully, but it's encrypted, at least. Our emojis, we've encrypted our emojis, which is important. And we're reporting all these metrics, we're aggregating them, and we're displaying in this dashboard. You might have noticed a little Grafana logo here, so we can even see. We pre-generate these Grafana dashboards per service, and there's other ones that are included out of the box, so we can see how success rate, for these things is actually not that great. Okay, is this making sense so far? Great. I'm going to show off one last thing, and then we'll do Q&A. So you may have noticed that success rate's actually not that great, right? Because of that bug, right? And so now we have some actual numbers around that. Okay, so we can actually start with this web deployment here. And the way to read this is web is in the middle, and all of the sources of traffic for web are on the left, and all of the destinations for traffic are on the right. We're drawing this picture automatically just from metrics data. And so we can see that here's my bot that's sending, it looks like closer to 2 requests per second to web. And so web has a paltry 96% success rate. It's dropping, right? But we can see that it, in turn, calls these 2 services, and it's actually this voting service that seems to really be failing, okay? let's click on that thing. And see that voting has only one client, which is web, has no dependencies, so it's just a standalone service here. If we scroll down a bit, what we are seeing here is a sample of the live calls that are happening through the system. These are gRPC calls. Linkerd is fully gRPC ready. And we can see, actually, that if we sort these things by success rate, that one of these calls has failed. Everything else has been 100%, but one of these calls has failed. OK, there's 3 now, 3 occurrences of this that have failed. OK, so we can watch this a little bit longer, but basically, this call is the culprit, right? So basically, the journey that I have taken you on is from, hey, here's an app, and it's running, and I know it has a bug because I can see it, to, oh, Kubernetes thinks it's running, so everything's fine, to here is the exact success rate, to, oh, here's the service that's failing, to, oh, here's the call on that service that's failing. It was all done without modifying the application. So that's just a very, very small sample of the sort of stuff you can do with Linkerd. I hope that made sense to you. And I'm going to pause here. There's a lot more to demo, but I'm just going to pause here. Since we have about 8 minutes left, I would love to take questions. Everyone's dumbfounded. I'm going to put this up here. While we're thinking about questions, everything you see is on GitHub. That's where we do all the project stuff. Community is centered in the Slack, but there's other forums. We've got mailing lists. We do a community call every month. We've got a formal security audit where they were blown away by how incredible Linkerd was. And we're a collection of friendly folks. OK, now before I call the first person, I want you to remember what I said. OK, this guy's giving me the nod. All right. How does Linkerd compare to Istio? Oh, that's a great question. Yeah. So I always get asked that question. It's like the first question. Yeah. I don't want to speak too much for the Istio project, but I think the goals of the 2 projects are similar, right? There's a set of features around reliability and security and observability. There are some differences in opinion, and but I think the biggest in the scope of that feature set. But I think the biggest difference is the focus, right? So the focus for us is on minimizing operational cost as much as possible, even if that means we have to be slower to add features. I think the focus for Istio is quite different. But you should take both of these projects and you should compare them. You should download them and do a little POC with both of them, because I think even though the goals are the same, the resulting shape of those 2 projects is very, very different. Great question. Thank you. Yeah. Up front. Yeah, so that's right. So that's a good question. I don't have a great way of showing you a breakdown of the status codes. What I can tell you is that 404 was a translation by the web front end of a gRPC error. And gRPC has this weird status thing where everything is a 200, but you have a gRPC status that's like unknown or OK or something else. So that's why you saw a 404 on the website, but you're just seeing this like not successful thing over here. Does that make sense? Actually, let me see if I can sorry. Let me try one thing here, because I think we might actually break this down. I just lost the call. Stateless services. All right, let me wait for this thing to come up, and then we'll do one more investigation, because I think there is a way of showing you the status code. Hold on for 1 second, because I want to do this side of the room. OK, way over there. Yes, you. Yeah. Yeah, that's a really good question. So the question was, how does Linkerd deal with the fact that some of this stuff kind of naturally gets into developer concerns? So circuit breaking was one example. Even potentially things like retry policies, are developer specific. So there, what we've tried to do is design the Linkerd APIs in a way that, at a minimum, the way that they attach is to the core objects that each role would be involved in. That's a little complex. So for example, for retries and timeouts, we have this idea of a service profile, right? And a service profile attaches to an individual service, right? So it's kind of in the developer's area of expertise, and it configures exactly how retries and timeouts work just for that service, right? And you could potentially do that in 700 different ways. The way we've chosen to do it is try and attach it to the domain object as much as possible. So it's not a complete solution, it's not a perfect solution, and I think this is still an area that the world is figuring out, because obviously there are these two teams, at least two teams, often there's a security team and other teams involved, and they each have different things that they're interested in and different things that they're able to control. But yeah, I think that's the first step for us. I hope that makes sense. Okay, over to this side. Yeah, so does everything have to be in the same cluster to get these metrics? What happens if the caller is coming from the outside world? So there, Linkerd does not have its own ingress. We rely on you setting stuff up with ingress. If you set things up correctly and you propagate some headers or forward some headers or something, we can basically answer the easy version of that question, which is we can give you metrics. Once you start getting into things like identity and stuff and multi-cluster things and can you preserve identity across calls, that's where things get a lot more complicated. But the easy version is yes. Great question. Okay, I'm bouncing back to this side of the room. Yes, you. Linkerd identity. Any integration with Spiffy? Great question, no. I'd like to at some point. But right now we try and do the simplest thing possible, which is we just take the Kubernetes service account, and that is your identity. Yeah. Once we get into multi-cluster mesh expansion stuff, then things like Spiffy become a lot more relevant. Yeah, great question. Okay, I know I apologize to someone on this side. Okay, yeah, over there. Yeah, so the question was basically how does Linkerd integrate with open tracing? How well does it integrate with open tracing? And the answer is great integration. Distributed tracing is complicated. There's a long blog post we wrote about this. What the service mesh can do is actually quite minimal, right? You still end up doing most of the work. What the service mesh can do is in the proxies we can emit a distributed tracing span, right? When traffic goes through the proxy. But we need you to propagate headers in the application to do that, because otherwise we can't tie incoming requests and outgoing requests in the presence of concurrency. So we do support open tracing, but the reality is Linkerd supporting open tracing is 5% of the work you're going to have to get to actually get to the point where you see a distributed tracing dashboard. Yeah, yeah, go ahead. Yeah, so in Istio there's a mixer. Mixers have adapters. Adapters can connect to various things. In Linkerd there's not really an equivalent of that yet. We want to get there. I want to do it in a way that is not the way that Mixer does it, because I think that's responsible for some of the performance issues in Istio. But we want to get to that point. And I would love a pull request with even an issue with a very specific set of criteria. That'd be great. So we are at the top of the hour, so I'm going to wrap things up here, but I will be here afterwards, so feel free to mob me with adoration/questions. Thank you very much for attending. I really appreciate it. My name is William Morgan.